Okay, so today we're going to be dealing with solving nonlinear systems. Nonlinear means what? Not in a straight line. So it means you could have a straight line, but you could also have a non-straight line. So for instance, you may have a parabola and a straight line, solving those linear systems. Okay? So what I want you to do on page 65 of your student journal, I want you to work with your groupies. Go ahead and match up those systems. Remember, a system is when you have more than one equation. Match up those systems to their corresponding graphs. Okay? I'll give you a couple minutes to do that there. Have a reason why. Okay, so A. Which graph does letter A go with? A. Now, if they're all that easy, it's going to be easy. How about B? E. Okay. C? F. D? E. C. All right. Very good. Hey, what are some strategies you use to match those up? Walsh?
For some of them, like A, you could just look at the, I guess A is a bad example. For C, you could just look at how it was like negative x plus 1 for the linear, and so if it sloped down, you knew it was up, and that was the only one that sloped down.
Okay, so, yeah, the only one that sloped down have a negative slope, so you find that right here, and you're good to go. Okay, any other strategies? Autumn? Okay, so just looking at the negatives, use graphing calculators to check. Dallas? Okay, so find all the vertexes of the parabola and then match up the vertexes up here. Okay, so find the vertexes. Good. Did anyone rule out, like, you're like, well, I know that this one is linear and quadratic, that one's linear and quadratic, that one's linear and quadratic. Therefore, I've got to match it up that way. Okay, it kind of narrows it down a bit. All right, so our solutions, all right? I want you to find the solutions to each of those. Find the solutions, at least kind of estimate if you can. Just figure out what the solutions of this graph. No, for all. The solutions to the system. And that's all I'm going to tell you. So, what's it look like on a graph when you have a solution to a system? Aaron? Good. Where the two graphs intersect. Those are your solutions. I mean, really, that's as simple as we're getting with it. So if you didn't know that, well, now you know. If you hadn't recalled it, there you go. If you refer back to linear systems, when we did linear systems, we where two lines cross. Okay? So we had multiple ways of solving linear systems. All right? One of those ways was graphing. And you found out where they cross. So just a really quick review about systems. If I, for instance, had the system x plus 2, y equals x plus 2, thank you, y equals x plus 2, and y equals x plus, or actually, let's go minus 1, okay? And we better do negative x there. Otherwise, we have parallel lines. That's not good. All right, x plus 2. Go up to the y-intercept of 2, rise 1, run 1. We have a line that does something like that. Go down to negative 1. We have a line that does something like, let's see here. These lines should be actually perpendicular, but you know, quick sketch. This would be our solution. Now, we solve these systems in multiple ways. Okay, I'm going to call this one y1 and y2. This is y1 and y2. Okay, we graphed them. We came up with a solution. We used substitution, where we said, hey, set that. Since it's equal to y, and that's equal to y, I can set them equal to each other and say, well, that's negative x minus 1 equals x plus 2. And we used, what's the other one? Elimination. Elimination was our third, and that's where we added them together. How many remember doing that? All right, well, you're going to do the same thing today, but they're not all going to be linear. All right, so in this one, we've graphed them. if I take and look at this function right here, what was this solution right here? 2, 4? How about this one? It's kind of hard without a grid, right? You kind of estimate, think it's right. You can check it though. Okay, and you guys, I haven't looked at your quizzes yet at all, but it grades some like my other classes' quizzes. And one thing that I'm noticing with, students is, and it's probably the same when I was in school, but they're not checking their work. I mean, you finish, but you don't check. I mean, you check, just throw them in. 2 is x, 4 is y. Put in 2, 2 squared is 4. That works. 2 plus 2 is 4. That works out. Negative 1, 1. Plug in negative 1 and square it, you get 1 out. Negative 1 plus 2 is 1. It works out. Okay? We could also go through and use a table. I want you to put both of those in your graphing calculator, please. Okay, we'll just use the equations now. Okay, once you get them in there, I want you to go ahead and look at your table. Okay, and our graph looks like that. We already know that, but go to our table. When you have an input that gives you the exact same output, so my x's are my inputs. This is y sub 1 and y sub 2, right? Y sub 1, y sub 2. Okay, my input of 2 gives me an exact same output. My input of, if I go back over to x here and scroll up, my input of negative 1 gives me the same output for both. So my input of negative 1 gives me an output of 1. That's a solution, negative 1, 1. My input of 2 gives me an output of 4. So that's a solution, 2, 4. Okay, and we know that because of our graph already. So we could use a table. We could use a graph. Let's go ahead and solve it algebraically. I want you to, on your note page somewhere, let's go ahead and write those down. Y equals x squared. And y sub 2 equaled what? X plus 2. Okay? So I want you to use substitution right now to graph that. Or, excuse me, to solve that. Okay, substitution, you're setting y equal to y, right? And so we're calling one of those y1 and y2, but it's still y equals y. So you're saying x squared is equal to x plus 2. And then you solve. Why do you do that? Well, that becomes a quadratic. Right? So we get x squared minus x minus 2 equals 0. And then you can factor. What's that factor to? X minus 2, x plus 1. And that gives me a solution of x equals 2 and x equals negative 1. Well, is that our answer? Remember, a solution to a system is a coordinate. We found 2 and negative 1. Right? Well, 2 and negative 1 are our x values. How am I going to find the y value if I'm doing it algebraically? Yeah, you just plug it back in. So pick an equation, maybe the first one. If you want to be really careful, you do it in both and make sure they both work. But if we put it in the first one, that's 2 squared. And that means y equals 4. Okay, so this is the order pair 2, 4.
Wait, how do you know the first one is the 2?
I'm just plugging 2 into one of the two equations. I could plug it in here, right? 2 plus 2 is 4. Okay, and then I plug in the negative 1. Zach?
Is there a way to figure out, kind of like how we did with the quadratics, how many solutions it has?
You'd have to graph it. Yeah. I mean, if you want a picture of it. Yeah. You could use y sub 2 and put the 2 in there, right? 2 plus 2 is also 4. So either way, you get an output of 4. So you get the order pair 2, 4. And so I'm just going to plug this negative 1 in. Y sub 1, negative 1 squared gives me output of 1. So I get the order pair negative 1, 1. One solution. The second solution. We already know those are the solutions because those are the solutions we got right there. But we now solved it algebraically versus having to graph it. So it's a little more complex than linear systems. I mean, linear systems, right, when we did that one a minute ago, when we did this one, that's pretty easy to solve. You just start moving the x's around and isolate the variable, but now you're dealing with a quadratic. So you get two solutions, you got to plug it in, and you've got to come up with two y values. And sometimes you're going to get no solutions because everything's going to cancel out. It's not going to intersect. Or it might intersect only once, like what happened right here. Okay, you get one solution. All right, how many think you got it? This is using substitution. What's the other method that we haven't done yet?
Elimination.
Elimination. Let's go ahead and take those same two. Now, can we eliminate anything there? Yeah, you could eliminate the y's, right? Now, some of your algebra teachers may have taught you to subtract the equations. I've always told my students you need to add them. But if I'm adding them and I'm trying to subtract y or add y's, that would give me 2y, right? Ignore the numbers, right? The numbers right now are just to tell you it's the first and the second, but it's still just y. If I add these two, I get 2y. So if I want to add them, I've got to make this one an opposite, or the top one an opposite. And if I make this opposite, I've got to flip all these signs. It's like multiplying that entire equation by -1. And when I add them now, these are gone. And I'm left with 0 equals x squared minus x minus 1, which will... Oh, I copied it down wrong. Thank you. That'd be 2. Thank goodness, otherwise we're going to have major issues there. Okay, now that gives me the exact same thing that I had right there. Therefore, I'm not going to go through that whole process again. Okay, you can use elimination. You get it, and you go factor it, and then solve for y. Okay, so 3 different methods. All right. Any questions? Okay, why don't you take a look at the extra practice, please. It's on page 68 of your student journal. Now, I will tell you, I really do try to work through. I've already worked through this one. When I go through these and I do them, I kind of make some notes myself. And one of the notes I made on this one was that, I already had a mark there, was that on these graphs that they don't give you pre-made grids for, like they don't tell you where your origin is, you really have to think about what you're graphing. Okay? So that the things will fit. For the sake of time, I'm going to tell you where I want you to draw your x and y axis. Okay? I'm not going to have us kind of guess and check on that. I think you should draw that one there. It worked out pretty well for me. Give this one a shot right there. Just kind of put it in the middle. And then this one worked well. Same when I raised it up. Okay, and really what I did to figure that out is I looked at the y-intercept on each of those. And then my slope. Or my how much I'm moving. So this looks really bad when it's magnified. I drifted off the line, but I'm not going to really use those grids much. What I want you to do right now is I want you to try number 1. Graph number 1. You do the other ones later, but graph number 1 right now. Okay? If you finish one, you can keep working. But this is your assignment, by the way, your student journal. Page 68 and 69. That's your assignment tonight. Okay. So, number 1. Taking a look at number 1, what ends up happening? They don't intersect. What do we call that? That is no soul, man. No soul. Lucian. No solution. All right, so you get a graph that looks something like that. Oh, hold on. Don't look at that answer. Whew.
She just made a span reference in math.
See.
Soul means sunny, so she said it's not sunny, and now everyone's
It's not sunny?
well, that's true.
It's not. I agree. That's kind of gross. All right. Okay, so you're looking for your points of intersection. Now, how many of you have done number 2? Or started it? Okay, number 2 works out, I think, pretty well. Let's keep on going there. We got number 2 and 3. Oh, hold on. Number 2 is the one that doesn't work out pretty well. But that's okay. Try number 2. Number 2 works. It just, well, you'll see once you're done. All right. So for number 2, here's what I get. That's what my picture looks like. I have something that looks like that. Okay. Now, how many got the answer? 2-0. Okay. Are there any other answers? Graphically, it doesn't look like it, right? Now, here's what I want you to do. I want you to go ahead and put the functions into your graphing calculator. Okay, and we hit graph, and we verify that, yes, it looks like it hits at 2-0. Correct? And you could even go to your table, and you're like, haha, 2? I get 0. Score. Okay, now here's what I want you to do. I want you to go to Zoom Box, and I want you to draw a box around this area right in here. Okay, we hit enter, and now we get a little closer look, and we're like, it still looks like 2-0. Oh yeah, you're using a cool one there. Let's go ahead and Zoom Box again. Now some of you actually using Desmos or one of those other deals on your phone. That works out pretty well. Lets you zoom in really fast. Okay, zoom in a little farther, and we're like, let's get a closer look. And, oh my goodness. It hits in 2 spots. That is absolutely ridiculous. Now, how were we going to catch that? Well, the way you catch it is you zoom in a lot when you have the chance of it hitting twice, or you solve it algebraically, which is what I did. And I got 2-0 and 2 1/4, 1/16. Woohoo! Thank you. Or you can use your algebra. All right. There's, by the way, the answer for number 3 as well. Questions? Yes. So the question: is there a way to find the value? You can go to second calc, and you're calculating a point of intersection. So option 5. Then you got to identify the curve. So first curve, yes. Second curve, yes. If you only have 2 curves in there, it'll automatically jump to it. Then it says guess. So in other words, bring your cursor closest to the point of intersection that you want to find, which in this case would be that one. Okay, so 2.25 and 0.625. Okay? I hope so. Okay, otherwise I did it wrong. All right? Good question. Let's go ahead and take a look at the rest of this page here. Make sure that you're understanding what's expected of you. So you can move down to 4 and 5. Solve by using the graphs. Hopefully you know how to do that after our warm-up today, or our exploration. Solve using substitution. Remember, when you're doing substitution, make sure that you take one, like y equals this and y equals that. You can set them equal to each other. You guys, I will tell you that number 6 is the toughest one on this page, I think, personally. Okay, so besides number 2, which was tough to find. Okay, but if you're going to use substitution, do number 6 last. Number 7 and 8 actually fall out really well. Okay, number 6, you get some weird answers. round to the nearest hundredth on number 6. If you get pretty answers for number 6, you did something wrong. All right? Number 9. Yeah, I know. Number 9, go ahead and turn the page. Number 9, you have some elimination. You got to eliminate some stuff. Since we didn't do a lot of elimination yet, I kind of like to at least start one of these together. I would rarely use elimination in this format when I have linear and quadratic. I'd probably use substitution then. I'd solve for y. But since it says use elimination, let's go ahead and try it on that. Okay? Let's start this one. If I'm adding those two functions together, in this case, when I'm looking at it, it's kind of messed up. It's nice if you can kind of line things up a bit. All right, so if I was to rewrite the top equation just as this, kind of that same deal. I could move the 1 over if I want and make that 12, or I could leave it there. Maybe we want to simplify it first, so let's make that 12. We'll just get rid of the minus sign there. So we added 1 to both sides. Okay, that's, if you want to label that as equation A, that may help that equation B. All right, and then equation B here, negative x. I'm going to just put that under the other x. I'm going to put it under the like terms. Positive y. Well, y is on this side, right? So if I'm going to use elimination, I want to move this y over to here. That makes sense? And maybe move this 4 over to here. All right, so it might help off to the side here saying, well, that's negative x plus y equals negative 4. Oh, thank you. And so I'm going to subtract the y over and add the 4 over. When I subtract y and then add 4, I end up with negative x plus 4 equals negative y. And so now I have the 4 that I can put there, and I have the negative y right here. And that's nice because that becomes 0. X squared minus 8x and plus 16. And hopefully you recognize that right away as perfect square. X minus 4 quantity squared equals 0. That means x equals 4. And y equals 0. Okay? Now how do we know y equals 0? Yeah. Good. You can plug it in. You can plug it into this equation. When you put 4 in, negative 4 plus what is equal to negative 4? Well, negative 4 plus 0. We've got it. So we have the ordered pair 4, 0. So this only hits once, right? Okay. And then you have questions 12 and 13 that you're going to do your bestest on. Yep. All right. You can go at it.